Ladies and gentlemen, please welcome SAE International's Chief Executive Officer, David Schutt.
Good morning and welcome back to the Exchange and day 2 of the WCX 2019. We hope you're enjoying the energy and the excitement of having not only the general sessions but the Leadership Summit and the Tech Talks right here in the middle of the exhibit floor. We're making the great experience for exhibitors and attendees alike, and we really encourage you to go and circulate and see some of the latest technologies that are out there. We're enjoying the steady foot traffic, and I also hope you're enjoying some of the autonomous vehicle traffic in the halls next to us. Yesterday's theme, autonomy, was a great opportunity to explore the engineering challenges, safety implications, and the potential of safe self-driving vehicles. I hope many of you have had the chance to go next door and enjoy the autonomous car, or even explore the J3300 Skills Certificate experience. How many of you have tried driving the vehicles and earning your certification? All right, we got one in the back. Way to go. So if you've been missing your daily commute, I encourage you to go over there and you'll experience a whole new commute in a stress-free environment. So today we're going to continue building on the autonomous theme with a focus on mobility and the digital ecosystems. As we keep innovating at the vehicle level, we also need to place the vehicle in context. With that, it's critical to give serious thought and attention to artificial intelligence, privacy, and other factors that affect everything from the physical safety to consumer confidence. After our keynote this morning, you'll find tech talks, connect-to-car roundtables, and a wealth of other technical sessions that address these and other topics. So clearly, there's a lot to take in at WCX in the areas of advanced technology. Yet, it's just important to keep focus on the people who make it all happen, and that's you and your colleagues here in this room, from the seasoned engineers to the young future engineers. And another program note I'd like to make is on the far side to your left, we have a whole hall of about 500 young school-age children. They're the future of our engineering workforce of tomorrow. I encourage you to go over there and experience and maybe even get down on the floor and help some of these children understand the excitement of the engineering process. They're going to be looking at our World in Motion jet toy competition. It's from 9 to 2 o'clock today in Exhibit Hall A. In addition to creating the future generation of engineers, tomorrow we're also going to be taking advantage of the best of the minds in the mobility engineering world. I think it's important that we engage all the minds. And to that end, we'll be holding a women's panel and a networking breakfast tomorrow, where the female thought leaders from our industry and from outside the industries will be talking about the tech disruptions and the cultural transformations that are taking place in the industry. So again, that's tomorrow from 7:30 to 9 right here in the Exchange. So a final program note that I'd like to make for you is tomorrow evening, we are not going to be having a banquet, we're going to be having a gala. No formal talks, no long program. What it is just a fun, relaxing evening, an opportunity for you to finalize some new contacts that you've made, deepen those relationships, or just continue the year-long conversations that you've been having with some of your longtime colleagues. So that'll be from 5 to 7 tomorrow morning, or tomorrow evening, down in the atrium. So we look forward to hosting you there. As far as I'm concerned, everyone here has to come there because you probably made at least one new contact. And now, what I'd like to do is introduce our keynote speaker. He's the Executive Vice President of Intel's Mobileye subsidiary. He's not only responsible for the company's autonomous driving and advanced driver assistance portfolio, he also oversees the Sensor Fusion R&D group. Ladies and gentlemen, please welcome Erez Dagan.
Good morning. We're here to talk about designing a safety solution for autonomous driving. The title is The Path for Safety from Humans to AV and Back, and we will see what we mean by that. So coming to design an autonomous vehicle safety solution, we need to ask ourselves hard questions about how the vehicle interacts with human traffic, how it complies with norms of safety and agility. What is the burden of proof of such a vehicle? What does it need to demonstrate by design or in practice? And what you could see in this video that we just played is a vehicle, try it again, a vehicle stopped in the middle of the highway, causing vehicles to negotiate their way outside to the next lane, where they need to demonstrate that cautiousness and agility simultaneously. So what is the right path to safety, to safely integrate AVs into human traffic? Could we assure AV decision-making complies with the human norms, as we said? Will such a process yield overall road safety benefits? And how long until it does? Let's inspect human road safety framework before we start designing something that interacts with it. So the first layer of humans' road safety system is the traffic rule. It's explicit enforceable instructions encoded by on-road, roadside visual indications. You all know them. This is an underdetermined system in terms of safety, in the sense that even if all agents comply with all these explicit traffic rules, there's still a risk of accidents. The reason for that is that if we would limit ourselves to solid lane marks or just signal junctions, it would impractically harm the traffic flow. It's not a very practical reason. So we're leaving room for negotiation. When there is any trajectory conflict, when you want to change lane, for example, because there is a dash lane that allows you to do so, when you want to turn on right on a junction, you need to negotiate with the other road user that has that right. So in a sense, it's incomplete. It's just the first layer of the safety framework. The second layer is the principles of cautious driving. These are a set of generally applicable driving principles put in place in order to regulate negotiations, minimize time-critical conflicts. You want to not find human drivers too frequently in time-critical conflicts where they need to over-calculate and make harsh decisions. Things such as keep safe distance, merge cautiously, slow down given visibility challenges, etc. Now, the second layer, unlike the first one, is much more implicit. It's very hard to interpret exactly quantitatively what it means, and in a sense, it is a social contract. We're all doing that because we're all better off if we do it. It's not a formal contract that is followed to the letter, because there's no letter. So, although it's a key pillar of the safety solution, as we understood, of the human society, there's a lot of holes in this bucket. Its general form, implicit, requires non-trivial application in real time by the drivers. Aspects of lapse of judgment and time pressure could definitely lead to an accident. There's no quantitative measures, it's interpretable. It weakens any contract, this one in particular as well. And it's very hard to enforce such that the compliance rates are cultural. There's a complete difference between what are the levels of compliance you would encounter in Boston versus San Francisco. For AVs to safely blend into such traffic, they need to comply with that, as we started by saying. So obeying to the traffic rules is easy. What exactly does it mean to obey to this social contract? In order to participate in the social contract, we need AVs to follow some digital interpretation of it, which is explicit, concise, metric, machine interpretable, and is of traceable logic. It has to be sound. It has to organically fit with common sense interpretation of humans of this contract. And it has to be pragmatic. It cannot become overly conservative and harm the traffic flow. It can be an overly conservative interpretation of that contract. We have published a paper that presents exactly this kind of an approach of building that interpretation of the social contract, a digital interpretation of it. It's called the RSS, Responsibility Sensitive Safety. What it does is formalizes the human common sense of agents' responsibility for cautious driving. It identifies and digitizes the principles and set underlying kinematic assumptions to reflect plausible worst case. Let's talk about this one for a second. When we're keeping a safe distance behind another vehicle, there is an implicit assumption of what's the worst case braking power I'll be able to respond to as a human. When I'm driving next to a parking vehicle, there is an implicit assumption of what's the worst case speed of an object darting from behind that occlusion as a human. That assumption is not a child on a jet engine, and it's not a braking power of 10 G. There are some plausibility to these figures. It has to be something that we frequently encounter, or it's a worst case, but it's still plausible. We then use these formalistics and derive a real-time accessible definition of what is a dangerous situation. That's in order to actually be able to act upon these principles that we just digitized. We also derive the proper responses, formally proven, formally mathematically proven, to secure the contract compliance, the contract that we talked about. Meaning that the definitions of dangerous situations and our responses to them gives us mathematically proven guarantees that if all other agents comply in the same manner, there are no accidents. That's a very strong statement. The implementation involves a quick look into the logical structure of an autonomous vehicle. An autonomous vehicle is comprised of perception module, planning module, and an actuation module. The RSS monitors the safety critical environment, not the entire environment. It only needs to look at things that could affect compliance to the contract, and adjust the trajectory produced by the planning module as needed. It overrides any planning that could have been done. Let's look at some examples. The nice thing about unexpected road events is that they put the safety concept of autonomous vehicle to the ultimate test of maximizing the agility while preserving strict caution compliance. Okay? So what we see here is a vehicle stopped in the middle of the road and vehicles are negotiating to the left. The black vehicle with a sticker on the roof is our vehicle, and now we'll look from within the cockpit. I do believe that that without letting you know, you would not be able to disambiguate that vehicle from the crowd, which is a very good indication for us. Okay? So as we look at this video, let's give it another look and let's look at the colors. Once again, vehicle stopped in the middle of the road. I do want to stall for a second on the visualization that we saw. So our car reaches it, no hesitation, starts to negotiate, really assesses which of the vehicles should be given way and which of the vehicle may be taken way of. And on the left side of this, on the right side of the video, you can see red and green coloring, which display the vehicle's understanding of which vehicle it could take way from and which vehicle it cannot. Again, based on that formal contract that we have digitized. The principles are very simple. It's a very sound system in the sense that it has a small number of spanning principles, which gives it a very high generalization power to any possible road topology or traffic condition. These are all principles that you would feel comfortable with in the human language. We'll then see them in the machine language, which is a bit harder to squeeze. We'll just run through it. So preserve a safety corridor. That's straightforward. You want to preserve a safety corridor such that you will not hit someone from behind if he brakes. You want to respect others' safety corridors. You don't cut in recklessly, as we just saw the vehicle doing, being respectful of other vehicles' safety corridors. Right of way is given, not taken. That's a very common human system sentence, human safety system sentence, which makes a lot of sense and makes also a mathematical sense. It comes out when you try to prove, to reach a contract which gives guarantees. You need this bit in order to give those guarantees. Visibility awareness deals with the cases where the agent's visibility due to occlusion or due to weather conditions is limited, and there needs to be some cautious, extra cautious display, taking that into account. And the last, avoidance may not become a cause. That's another important principle to make that contract formally provable. Avoidance may not become a cause of another accident. So the 5 principles are used to span all negotiation scenarios and road topologies, as I just said. You're welcome to take a look at our website, where we detail a lot of a body of work of our engagements with standardization, regulation bodies, and research labs around the world. Just to see how it looks in the scary language, we'll run through these. This is the definition, the formal definition of longitudinal distance, safe lateral distance, dangerous situation derived definition. How do we detect the moment of dangerous situation? And what is the proper response in that case? How does it look? And then, of course, we're not only driving on highways with parallel lanes. How do we generalize to merge intersection points of different road geometries? Again, it's very tedious, but I just wanted to give you a sense of how it looks to span from five principles to this complexity on the road. Limited visibility in occluded areas, we need to exhibit caution, which is adjust the driving speed or the lateral offset of the vehicle, considering the plausible worst case behavior of that invisible object that they can't see right now. This is a very nice example of a completely machine-driven vehicle in a very complex scenario. As you could see, from these very simple 5 principles, we can deal with very high levels of complexity. You can see the vehicle very cautiously not overtaking and not violating the other vehicle's safe corridor, patiently waiting for that pedestrian to cross, and moving along. There was no better strategy, no better tactic to take in this scenario as a human that observed it. It's a very natural feeling kind of a behavior. So Erez has, apart from being a mathematically proven contract, has several very important attributes that makes it a very strong asset to the AV industry promotion. It contributes to the perception, design, and validation. Since it's based on a formal model, we can derive an efficient set of test scenarios to put an autonomous vehicle before we deploy it to the road. The fact that it's explicit and kinematic with kinematic parameters allows 2 interesting things. First of all, to structure the very important discussion between regulators and technology makers. We can structure that discussion, give it a way to proceed in tackling the right problems and the right questions. What should be those parameters? And also very important, we can model what is that human common sense. Since there are parameters in place and we have a lot of data on human behavior, we can simply fit the data to the parameters of the model and find out what exactly is that plausible worst case speed that we assume of a darting object, for example. So now we started off by trying to understand the human safety system, when we ended up into an undeniable opportunity to dramatically improve it. Digitizing the principles of cautious driving, turning the social contract from implicit and general to explicit, traceable, formally proven, and enforceable one, tackles a key cause of road accidents. Human negotiation is far from flawless. it's far from clear. It's far from consistent. Negotiations vary in results based on the time utility of the agents, their risk averseness. There is no clear rule to follow. And yes, humans have very good capabilities of building experience, but that doesn't give us the comfort of a formal, airtight contract. Okay? Having another, from the other side of it, the model gives us a very clear boundary line between what it is to be agile and what it is to drive dangerously. Once you have that boundary line, you can optimize the agility. That's a very important one. When you have that boundary line, the autonomous vehicle with the very low response times that it has can really squeeze that lemon, can really take that to the extreme. Now the main question is that we have a great model at hand, but for the upcoming few good years, autonomous vehicles are not going to be but a fragment of the vehicles traveling on the road. How can we leverage this model sooner? So there's a lot of interplay between autonomous driving and driver assistance. Autonomous driving is kind of an incubation lab for us in Mobileye of more advanced technologies, which we trickle down into ADAS and monetize on. And very importantly, the ADAS space, our strong leg in ADAS helps us qualify our components when we plug them into the autonomous driving. We can build bottom up from battle-tested components. Our pedestrian detection module, for example, has been driven billions of miles out there in our ADAS systems. It's a very good point, pro. When we look at ADAS, it's interesting to see the duality of the term driver assistance. In one case, the driver assists a system, if you think about adaptive cruise control. In another case, a system assists the driver when you think about autonomous emergency braking. Always there is a someone is safety monitoring the other. And that duality will come back again. So one of the interesting points of interplay between ADAS and autonomous driving is this crowdsourced mapping venture that we have kicked off 2014. We're using the proliferation of millions of vehicles, ADAS vehicles out there, to aggregate, dynamically cure a high-definition map of the world, which can then be used by autonomous driving, and as we will see, not just autonomous driving, to navigate the roads. It dynamically cures, it captures changes in very small latencies. We call it TTRR, very low time to reflect reality. As you can see, the map being built, it's a huge asset to have this geographical dispersion of our ADAS systems out there, ADAS cameras out there, and this technology leverages it very well. Level 2 Plus is kind of the first love child of ADAS and autonomous driving development. It bases on the crowdsourced mapping venture. It started off from that. That's the first thing that glued the things together. But it allows us to deliver what we would call pseudo-autonomy. Okay? Level 2 Plus is a vehicle that doesn't change the liability structure. The driver is still responsible to monitor and to be available. His mind is on the drive. But we can get a very expressive and a very rich envelope of operation based on technologies trickled down from autonomous driving. The key ones being road experience management, or our crowdsourced mapping and localization, and surround cameras, set of surround cameras on the vehicle. Having these two components trickled down to driver assistance, to the mass market of driver assistance, allows us to deliver this pseudo-autonomy proposition. The next logical step is, of course, okay, so if autonomous vehicles are going to create that revolution in transportation a few years to come, if we trickle down RSS to these advanced driver assistance vehicles, we will get a revolution in saving lives. We will get the vision zero reality much closer than ever. So the social contract that I was talking about earlier can be applied to a very, very wide install base of consumer vehicles today. And we are in the process of promoting it with our partner OEMs and with regulatory bodies as well. So what the kind of evolution it offers ADAS is interesting. We're starting with ADAS today, which is more emergency response to predefined set of scenarios, which are sampled very, very rich set by today, but by no means a comprehensive, formally proven driver assistance. That's not out there yet, okay? So the first one is to turn it into, to generalize it based on the RSS into a holistic emergency response system. Second interesting step to take is to turn it from emergency response system to a preventive system, a system that makes sure that you do not enter an emergency situation to begin with, not just to respond when you do. We can skip that. That's the difference between preventive and emergency braking. Last but not least, how can we harness the crowdsourcing in favor of road safety? So as I mentioned, surround vision system supports RSS cautious driving assessment. The RSS is the model, is the contract we said. So we're using a surround set of cameras to continuously monitor the safety critical environment and assess whether we are in a dangerous situation and whether a proper response needs to be taken. However, on top of it, our crowdsourced roadbook provides us with foresight of upcoming negotiation points, lanes topology, and lanes priority. This foresight of negotiation points is where we started this talk. The negotiation is currently the weak point of the human safety system. On top of it, there is an interesting layer of insights we can incorporate. Both these things gives the vehicle kind of superhuman perception. You see behind the curve, and you get a sense of what is commonly happening in this environment. If there is a right turn that commonly invokes emergency braking, you want to know that. There is some vulnerability in that point in the road infrastructure that you want to be aware of. So to conclude with some visuals of what it is to get dynamic data insights, here we see a new speed limit sign, a construction area that was set. As said, we gather also information about pedestrian crossing hotspots. It's great that there's a zebra cross there, but here's the Starbucks and here's a office building, and that's where the actual zebra cross here is, and you want to know that. So the non-necessarily physical road infrastructure. Okay, I'll conclude with a couple of videos that gives us a sense again of how far we can take it. Mind you that all of the videos that you saw today include only surround vision and a map. So in essence, all of the performance that you've seen on the videos today is suitable to be deployed onto ADAS in terms mass market, in terms of economics. And it's just there for us to take. Thank you.
Ladies and gentlemen, please welcome Ken Washington, Chief Technology Officer of the Ford Motor Company and SAE International's Automotive Vice President.
Well, good morning, everyone, and Erez, thank you so much for those insights. You know, you're doing some amazing work, and we just can't wait to see it get into the hands of the masses, and for everyone to benefit from the power of this amazing technology. You know, I don't know about you, but I get asked all the time, when is it coming? And so I guess the first thing I'd like to ask you is, can you give us some of your thoughts? How is Mobileye thinking about how this technology that you shared with us this morning will scale to the masses? How should automotive companies be working with Mobileye? Is that your primary path to scale, or do you have any other insights about how to actually accelerate the scale up of the technology so it can get into the hands of more people?
Terrific. So, by all means, we are working hand in hand with the automakers to proliferate the opportunity of this RSS implementation, which entails two technical elements: surround camera system to increase the fitment rates of those, and the crowdsourcing. The OEMs has this very important asset of geographical dispersion of vehicles, combined with our asset of the camera technology that can harvest useful information. I think it's very important for us to promote it in advance. The third layer of that effort is, of course, in front of regulatory bodies to get that discussion running in the right direction, get the right terminology in place.
Oh, excellent, excellent. As you know, Ford and other OEMs are already well on the path to adopting your technology, and we look forward to more of it coming into the products at scale. So,
and we recently promoted the crowdsourcing agreement with Ford, which is I look forward to taking the fruits of this very important asset.
Excellent, excellent. Well, as I was introduced, the hat that I'm wearing today is as the SAE International Automotive Sector Vice President. And in that capacity, Erez, one of the questions that I often get is, how is the industry going to approach validation? Because a huge issue is this notion of trust. We put our loved ones in our vehicles, and these vehicles are operating in sometimes very dangerous environments. So please share with us, what are your thoughts about, and how is Mobileye thinking about validating the technology to the point where you're comfortable with saying, okay, we now trust, and you should trust this technology?
It's a great question. So we were puzzled by it for quite a while until we have devised the RSS concept. The RSS concepts, the strength of it is that it is completely model-based, formally proven. Being model-based and formally proven, you can derive an efficient set of scenarios to which you need to validate your vehicle before you put it to the road. So it gives you kind of a checklist, which is much more concise than if you went at it and put the vehicle into millions of driving miles.
So that's really great. How will we go about educating the public about the trustability of that mathematically proven formulation? Us engineers might be able to hear you say that, and we get it, but that might be difficult for the public to consume. What are your thoughts about how we would do that?
Again, a great question, a hard question. So we are in multiple channels of discussion with standardization bodies, with SAE in particular. In China, we have a lot of traction, and with regulatory bodies. Importantly, we have started a very deep process with the Israeli regulator as kind of a spearhead in that sense, because we have a project that's going to be launched 2022 in Israel for mobility as a service in Tel Aviv, and we're clearing that regulatory environment around it. We do believe that through the regulator acceptance and regulator education, the trust will trickle down to society. The regulator is the gatekeeper, and is usually much tougher than the society.
Right. Very well said. Thank you. Let me shift gears a little bit now. I think we are all have the experience and have acknowledged that today we're hearing so much about machine learning and deep neural networks, deep learning, and some fairly bold claims about the power of these self reinforcing ecosystems, where the more data you have, the better the application gets, and that the better you are able to attract more more users and therefore more data, and then the cycle continues. And we've seen that formula be applied to the autonomous vehicle sector. Can you talk a little bit about how your methods work in concert with that formula? And how should we be thinking about the trade-off between a more mathematical approach and a more deterministic approach, rules-based if you will, and a more data-driven learning system approach?
Great question. So, data-driven approaches has the huge strength, undeniable strength in building very expressive machines, very machines that can take a lot of interesting decisions. A lot of the decisions that you saw, the will to cross to the next lane when the pedestrian is in front of us is something that, again, the machine learning has done. But if the risk of machine learning is that you cannot learn black swans. Okay? And that's where it comes.
So explain black swans to us.
Yes. Black swans are very rare events, and machine learning, which is data-based, is by definition not generalizing to these rare events. Is not capturing the complexity to that extent that it can predict black swans. So we have a very strict statement. When it comes to safety, machine learning is not the tool. When it comes to securing the safety of the vehicle, machine learning is not the tool. This is exactly why we built a model-based, not a data-based framework, RSS. And again, if you link to the examples that I shared earlier today, the vehicle's planning block that I showed also in the diagram is indeed machine learning, but it can be overridden at any minute by the rules-based, the very strict principles of cautious driving that we have articulated in a model-based, bottom-up manner, not data-driven.
Excellent. Okay, well, that's really great insight. I think that's going to give us a lot to think about. Let me ask you about some of the terms that you've used in your talk. And there's been so much discussion about autonomous vehicles, and it's introduced new language, the levels of autonomy, and we've all used the L1, L2, all the way up through L5 definitions. But you added a term L2 plus today, and I've seen that term used before, but it's not always used with the same definition. Same goes for L3, and unfortunately we've seen a lot of variety in how people use these terms, which sometimes leads to, at best, confusion, and at worst, some potential safety concerns because of over-reliance on a system that's defined in a way that's different than the user might believe. What is our role in the what are your thoughts about what the automotive industry, including the supply base, companies like Mobileye, can do to bring some clarity to that? How can we educate both the public and begin to use more consistent and common terminology?
I'll start by saying that the SAE levels of autonomy is a great success in the sense that it did add a lot of clarity to that discussion. I agree with you completely that the end user might not necessarily be as affluent with the terms. Maybe I'll just say it first very clearly. Anything that is lower than level 3 assumes that the driver is liable for what's going on in the vehicle. It's very simple. Anything, it could be a level 2 plus, level 2.6. It doesn't matter. Level 3 and above introduces different types of autonomy. Level 3 is conditional autonomy, just in certain conditions, where the driver may be summoned to take over again and become liable again, but the vehicle is liable under certain conditions, specifically or commonly traffic jam pilots and highway pilots. When we talk about level 4s and level 5, which is the utopia, level 4 is full autonomy, meaning that a vehicle could stop, is liable for what's going on, and could handle with exceptions all the way to reaching a safe state. And then it can call the driver or whatever. But I completely agree with you, there's a lot of room for education of customers, and OEMs need to start really being very explicit about it. It's not a matter of promoting a product It's a matter of keeping clarity and safety. And I think OEMs have been very responsible so far in these areas where it comes to safety, safety of the roads. And I do believe that they will resume that responsibility again when it comes to the market.
Well, thanks for your thoughts on that. Maybe I could expand it a bit and ask about two other terms that we often hear about, and that's the generic term autonomous vehicles and also self-driving vehicles. How would you define those two? And do you think it's the use of the generic term autonomous vehicles is something we should continue or discontinue or only use with clarifying qualifiers?
Yeah, I believe that when we say autonomous vehicle, I would interpret, and I hope that others would interpret, as liability lies with the vehicle. That's the dividing line, whether liability transferred from the human to the vehicle or not. And maybe that's the main bit of information that would be efficient for OEMs to communicate.
And what about self-driving vehicles? Where does that land from your point of view?
For me, it's interchangeable, the autonomous vehicle and self-driving vehicles. I think that the terms automated versus autonomous captures better that shift of liability. Automated driving versus autonomous driving.
Okay, very good, very good. One last thing, in the time we have remaining, could you give us a little peek behind the curtain? What are the remaining big challenges for Mobileye? What can you share with us some of the things you're working on? What will we likely see next?
So, as I said in this talk, one of our biggest items on our plate right now is to really proliferate this solution to the mass market. First of all, to get the autonomous vehicle technologies and safety concepts down to the mass market, to get it as soon as possible. But if we're talking about the autonomous driving per se, I think that the challenge that the industry currently or will be facing very shortly is to get the economies of these systems to a level that really take a stab at the global mobility problem. If it's too expensive to address a significant portion of the miles driven in the world, we're not tackling the hard mobility problem out there, which is what we set to do.
Oh, very good. Erez, you've certainly given us a lot to think about. You've opened our eyes, I think, to a lot of dimensions of the autonomous vehicle future and the ADAS world. So, thanks so much for your insight and your contributions to this important field. Thank you so much.
Thank you.
Please join me in thanking.
Thank you very much.
Ladies and gentlemen,
joining us.
please take this opportunity to join us for...
I'm not done yet. You know, look, it's always good to be part of an authentic discussion like this, and these are technologies that are shaping our industry. You know, we'll look forward to more conversations like this tomorrow, so please come back. Tomorrow we're going to focus on another important dimension of our future, which is the future of powertrain, propulsion, and innovation. But before we adjourn this morning, I'd like to remind you all to check the WCX app and event guide to scout out your own list of can't-miss product demonstrations, roundtable discussions, and career conversations. We are at a moment in time in our industry where this industry is in motion. And that means we've got to be in motion too. So there's no better place to experience that for yourself than here at WCX. Thanks for joining us in this conversation this morning, and have another great day at WCX.